This is my pre-calc 12 midterm project on Unit 4 logs. So you have this question: at what rate of interest would an investment have to be paid for an initial $900 to grow into $20,000 in 16 years if the investment was compounded quarterly? So for this, we'll be using the formula A equals P1 plus R over N to N times T. So for this formula, A is the final amount of money, which would be 20,000. P is the initial amount of money, which would be $900. T is the time it takes, so 16 years. N is the amount of times compounded yearly, which is 4 because it's quarterly. And R is the rate of yearly interest, which would be X or R. So the formula will look like 20,000 equals 900 bracket 1 plus R over 4 because it's quarterly, and then to 4 times 16. Now the first thing we'll do is, this is 900, not 9. First thing is to divide both sides by 900. These will cancel. This can be simplified as 20 over 9, which equals 1 plus R over 4. And then 4 times 16 is 64. Now what we can do to solve is we can log both sides. So this will be log 20 over 9 equals log 1 plus R over 4 to 64. And then bring this 64 here in front to logarithmic form. Log 1 plus R over 4. Now can divide both this log 20 over 9 by 64. So if we do this on my calculator, it will be log 20 divided by 9 divided by 64, which in short will be 0.005418 equals log 1 plus R over 4. Now this is in logarithmic form, so what we can do is put this into exponential form, getting rid of the log. So this log has a base of 10 because it doesn't show, so it's automatically 10. So this will be 1 plus R over 4. This will come over to this side, equals the base 10 to 0.005418. Now we can plug this into the calculator. So 10 to this number here, 0.0054185545, which will equal 1.0125. We can subtract this by 1 from both sides here. This cancels out. You get r over 4 equals 0.01255. And then you will multiply both sides by 4 to get r by itself, leaving you with r equals 0.05021. Now, we want this in percentage because it's the rate of interest. So we will multiply 0.05021 by 100, which is 5.022. And that is the answer. So we have the logarithmic equation here of log base 3 of x minus 4 minus log base 3 of 6 plus log base 3 of x plus 5 equals 3. Now the first thing we'll do, because each of these terms has log base 3, we can write this as log base 3 x minus 4 divided by 6, because it's the subtraction sign here. So we bring them together, it's divided by 6, and multiplied by x plus 5 because there's an addition symbol here. Multiplied by x plus 5 equals 3. Now, because we have a log, an argument, and 3, we can cut the log. So we'll be getting rid of the log and bringing this 3 over here. So it will be 3 to the power of 3. And this will be x minus 4 times x plus 5 divided by 6 equals 27. Now we want to just get x by itself. So we'll multiply both sides by 6. These will cancel. And you'll be left with x minus 4 times x plus 5 equals 27 times 6, which equals 162. Now we can multiply these two brackets together, and we will get x squared plus 1x, can be written just as x, minus negative 4 times 5 is negative 20, which equals 162. Now we want to get 0 on one side so we can solve for x, so we'll subtract both sides by 162. These will cancel. On the left side you'll get x squared plus x minus 182 equals 0. Now with this you can actually factor it, and it will be x minus 13 times x plus 14 equals 0. Now from here you take from this, you get x equals 13 and negative 14. You switch the signs when you take out x. Now if we go back to the start here, we notice we have x minus 4 and x plus 5. Here I'll rewrite this log 3, right, like this. You cannot take the log of a negative number, therefore x must be greater than 4, and x must be greater than negative 5. Now if you look at negative 14 here, it is less than 4 and negative 5, so that will not work. So, and 13 is larger than 4 and negative 5, so x equals 13, and that is the answer.